Hello everybody and welcome. We are live just a few moments after planned, just for a few technical issues, but we are live and that's all that matters. So we have got a superb show lined up for you. It's going to be about 45 minutes and it's hosted from this engineering technology group, and we're going to be talking about 3D systems and their figure 4 technology. And throughout the show, we're printing live. So we started the machine about 20 minutes ago, and we're printing this pen here. This pen, at the end of the show, if you show your interest, just message us and let us know, and you can take one of these home. And what's so good about this is the fact that you're seeing it printed live, and you can see, get it home, touch it, and see the quality of this part. So, like I said, it is live, so we want you to be as interactive as possible. So grab yourself a sandwich or a cup of coffee as we're going to explore the figure 4 3D printers and what these can achieve, where they sit in the marketplace as well, in the modern day machine shop. Like I said, we hit go on the printers, but let me tell you the lineup. So Paul and Steve are just standing by the printers as we speak. They're going to touch base on how ETG are not only a supplier of these machines, but also some case studies. They're also our hosts today, so we'd like to thank Steve for hosting the show here. Gareth, who is with myself, he's going to talk us through what we're printing on the machines. Really interesting information on materials and how they're made and where they sit in the marketplace, what we can create, even some ventilator parts that we're going to see made, printed on one of these machines. Sarah's going to give us a demonstration on quite simply how easy it is to set up, to program through the software. Really easy and simple. Literally, she does it in like 2 minutes. And then Steve and Paul are going to talk in detail, like I say, about where ETG fit with this technology and give us real life industry examples. Then Gareth's going to explain who 3D systems are and why go for this technology and this particular machine that is the figure 4. And then to conclude the show, we're going to show you these parts close up, and then you can get them home as well. So Paul, let's start by heading over to yourself and Steve.
Good stuff. Thank you very much, Lindsay and Gareth. Steve, good to be back at ETG. Good to be looking at a different discipline here today, a different sort of technology. Before we get into a little bit of detail about the partnership and the machines themselves, maybe you could tell us and excite and whet the appetites of the people watching as to what they could be the proud recipient of after today's show.
Yeah, there's a common question when people are investing in this type of equipment. That they want to see a finished product coming off the machines. They want to see the quality of the finish and how accurate the part is compared to the item that they've sent over. So what we're doing today, we've got 2 machines running, and the printed sample parts, we have a sexy pen then and some other functional elements, along with a brochure that goes through, highlights the 2 different models along with all the materials together. So if people inquired at sales@engtechgroup.com, and put obviously in terms of the live event, we're going to send them a nice package of a variety of parts so they can see what these machines are built for.
Do you fill the pen as well, or is it just the exterior?
No, yeah, we'll probably put some ink in it.
And you can see that this printer is actually printing at the moment, which is great, as Steve said, in real time. He just wishes that his hair would grow as fast as these pens are.
You can't talk.
Steve, can you maybe just give us an overview then of the partnership between 3D Systems and ETG and where it fits in your portfolio and really why they've selected you as well to be part of partner?
Well, 3DS and how they promote themselves is a full solution. You know, it's not just a desktop printer that sits on there and prints Yodas then. It is a full turnkey solution. So they reached out to ourselves as a turnkey provider, and now the 3DS is a real premium product, fits alongside our Chirons, Nakamura and Quasar or other principles that we represent.
Yeah, it's good. I mean, this really does now sort of make sure that you've got everything within your toolbox to be able to satisfy a manufacturing audience, not just subtractive now, but of course additive too.
Yeah.
Interested in questions, obviously we want people to ask us or ask Steve or even ask Gareth and Lindsay throughout the show as to things they want to find out more about on the 3D printing side. Steve, firstly, after hearing about the partnership, tell me about the 2 machines that are in operation here and maybe what the differences are between the 2.
So we've got the standalone unit, the modular unit. Quite simply, the standalone unit is what it says it is. It's a standalone unit. So, for example, you would take your step file, your model of the component that you wish to print, and that goes directly into the machine itself, and from there it will obviously print a number of parts for you, all controlled by the control panel on the machine itself. The one next to yourself, the modular, we have a separate PC that drives the unit itself. So what customers can do, they can upscale the modular unit, so they can add a number of different printers onto the machine, and it would all be controlled by one PC.
Now, coming up, Gareth's going to give us a lot more detail on 3D systems, the actual figure 4 models as well, technically. Sarah, as Lindsay said, is going to do a bit of a demonstration on the software and how you program these parts. But Steve, how does it work? I mean, what's going on in here?
Well, I can feel Gareth's eyes burning in the back of my head, so I'll give you the very, very basics. But under each unit, there's a simple resin tray where we pour in the different types of material, and from there we have a tray that you can see basically the finished part attaches to, and the tray rises like a Z-axis on a milling machine. And from there, with inside the bed, it cures that part, and the part grows from the resin, like Spider-Man 3.
That's fine. Okay, right. We'll learn a little bit more of the technical stuff as well shortly. Two more things from me before we go back to Lindsay and Gareth, Steve. Pricing. People look at 3D printing. Sometimes they might not want to get into it because it's a big investment, it's a big risk. But these are pretty competitive, aren't they?
Yeah. So if we start with the standalone unit itself, again, it's a flooded market for your desktop printers. That's not our route to market. We are a solutions provider. So with the standalone unit, you're talking less than £20,000 for that particular model, and then we ramp up onto the modular depending upon different options and materials and so forth that you can add into the machine itself.
Oh, okay, great stuff. And Lindsay's just said to me, easier to move than Steve is. How about that?
I'm not that static.
Back over to you, Lindsay.
Thanks for that, Paul. I can't have as much banter as those fair cans. So if you are just tuning in, welcome. We're live, and we're live from the Engineering Technology Group. We're talking about 3DS, so which is 3D systems and their figure 4 technology. I'm going to speak to Gareth in just a few moments, but if there's any engineers who are watching out there that already have 3D printers, we'd love to hear from you. Let us know the parts that you're making. Send them in. They could be really left field, but the more the merrier. So just tell us what you're making on your 3D printers at the moment. Of course, we're going to shortly see Sarah talking us through the software and how easy these are to program. But beforehand, right, I'd like to welcome Gareth, who is from 3DS. Thank you today for joining us.
Thank you,
Gareth.
Lindsay.
So, Gareth, can you tell me a little bit more about yourself and what you do at 3DS?
Yes, so I'm a regional sales manager at 3D Systems. Basically, this means I'm responsible for the sales of our professional 3D printers in Northern Europe. So I spend half my time in the UK and half my time in the colder countries.
Oh, nice. It's been quite cold lately.
Cold enough in the UK at the moment, yeah.
It definitely has. Let's talk parts, right? Okay, so let's talk about the pen today in a little bit more detail. I know Steve's briefly explained how it's made, but what about the material?
So I suppose today, we want to capture a wide audience. We want to show, a little bit of the history, what 3D printers are currently used for.
Yeah.
And, we're churning out a nice little bit of merchandise, a sample pen, could be considered a prototype or a development job. But more than that, we want to show how the technology can be used for real production. And I think that's the key difference with the Figure 4 platform, is it can span both worlds, the R&D lab, but also the production floor.
I find really, really interesting because not just the pen here, but you've got some other parts. You actually 3D print your parts and then use them within the Figure 4, is that correct?
We do. We like to practice what we preach. Yeah. So we will give you a real world example of a true production application. But the easiest and quickest example to give you is that some of the parts in the Figure 4 technology are 3D printed on the Figure 4 and ultimately our end use bits that go in the machines we ship to customers.
It's amazing because you've got so much confidence in the product as well. Let's talk materials now. What are these materials?
This really is it's one of our flagship materials. So, in the last 18 months we've made a real quantum leap in some of our material chemistry, which You know, having a printer that's fast enough to produce is one thing, but if you don't have the right material that the customers need, then it's just a fancy box, really.
You know what, I think maybe, are we all kind of guilty of forgetting that this is chemistry at the same time as what you're producing?
For us, you know, we say it's the material that fixes the customer's solution, and then the 3D printer is really the vehicle that just delivers that material.
And the quality of the parts, can you explain this?
Yeah, the goal really is, with this platform, is to deliver a quality of part that rivals and is comparable to a traditionally injection molded part.
That's what I was going to say, because we're going to find out a little bit more about batch work a little bit later and where they sit in the marketplace. But what about speed of making these?
So speed, you know, it's a four-way thing, really. You know, we need speed, we need quality, we need to produce it at a cost that is competitive, and you know, we want a scalable platform. So whether we're building a batch of 10 parts or whether we need to scale to tens or thousands of parts, you know, this is a platform that can do that. I think the key thing about this material is it offers a bit of everything. It's fast to build, so we've got a fast 3D printing speed. It's got really good mechanical performance, it's strong, and it's environmentally stable. So this pen that we're going to produce, unlike prototype 3D printed parts, this is going to last for a good few years and will perform functionally for a good few years ahead.
Wow, okay, so we've found out a lot about the machines, we've found out about the parts, but next, let's find out from Sarah how easy it is to program and how it works with the software.
I'm Sarah and I do the applications for the 3D Systems machines. I'm going to show you how to program the Figure 4 modular to set off a print job. So, we import the file. This is an STL file. And we insert it onto the build platform. This then needs to be orientated so that it's actually on the build platform. So we'll manually orientate it to the part we want on the bed. And then we'll need to auto place it so it actually puts it on the build platform. Once the part's on there, we need to add the support material so it holds it onto the platform and puts supports on any overhangs. So you can see now it's on the platform, it's got the support material on the bottom to hold it on. We can then copy this so that it fills up the platform. So if we select the part, fill up the platform, this will then fit as many parts on as it can print in one build. Once the parts are all on the platform, we can then add them to the queue, and this will send them through to the printer queue. So now the file's in the printer queue, what we need to do is mark the printer as ready and confirm the platform's empty by pressing it online. So the printer's now communicating with the control system and preparing the print job to print. The build platform's now descended into the material and is commencing printing.
It really is that simple. As I said at the beginning, it's only 2 minutes, and she's explained to us exactly how you can how you can use the software and program all of these parts. And I'm sure if you send your inquiries in, Gareth and the team will be getting back to you if that is of any more interest. Right, okay, so next up, I want to find out more about 3D systems, and something so exciting is actually seeing the parts here used, being made out in the industry. There's so much that you're going to explain to me now. So Gareth, 3D Systems, who are you?
Who are we? So yeah, I suppose in many ways we're the pioneer of 3D printing.
Okay, the pioneer?
The pioneer. So we invented 3D printing back in 1983.
Wow.
I say we, that's very much the
It
royal
wasn't you.
we. No, I'm too young. Chuck Hall, he's our chief technical officer, and he invented a 3D printing technology called stereolithography in 1983.
Gosh.
Interestingly, at the same time, when he filed the patents for that very first technology, he filed some patents for this thing called Figure 4. and this is the original patent drawing for Figure 4 back in 1983.
I didn't realise that it does date back that far. You know, you just think
the
it's
idea,
only now.
yeah, it's probably the longest machine development cycle we've had, 1983 through to 2019. But really, in 1983, the electronics didn't exist, the computers didn't exist, and the materials didn't exist.
Wow. And then the Figure 4, right? I want to know more about this technology.
So it's our latest technology platform. We released the system back in 2018. When we first released it, we had just the one version, the Figure 4 standalone, which is really the baby of the group.
The core.
The core, it's the all-rounder, so it can do a little bit of everything. It might be in the R&D lab, but you can also produce small quantities of parts. I think the key thing to take away from Figure 4 is it's a scalable platform. So it's one type of technology, and then we've got 2 or 3 variants of the machine, basically to match what your output or your throughput requirements are.
Which is quite interesting because you're talking about scalable. You're not just printing one part either. So within the machines, you can scale that up even further, can't you?
We can. You know, the standalone, you might be printing a few hundred parts a month. Then we've got the modular, which can hit, tens of thousands.
Wow.
Or we've got a fully automated production cell that in theory can hit tens of thousands or even millions of parts per year.
So what are the advantages then of using this technology?
Yeah, so it's a really robust platform. Fundamentally it works with a projector. So we're using what's called a photo-curable liquid polymer resin.
Right.
And the light from the projector then cures and turns it into a solid. Basically, there's very few moving parts in the machine, just some electronics. So we know it's the most reliable platform because we aspire to the reliability that you get with machine tools and injection molding processes.
Yeah, of course, and it fits within the same industry. Right, parts, this is so exciting because, of course, after the year we've had with COVID and everything like that, you've got some parts that were used, during COVID-19 and the ventilator challenge.
I've tried to bring in a selection. I mentioned I work for a printing company, but most of my parts are regularly stolen. So we've got some real live, if you like, relevant parts. This is actually our latest material for the Figure 4. This was launched just yesterday, so you're probably the first people seeing a part in this particular material. But you might be able to tell these are all ventilator and PPE related.
But the advantage of this is the fact that you've been able to source them quickly, produce them quickly, really, isn't it?
So, a big thing these days is localization, being able to access your supplies quickly and reliably. This was a key problem where there was a shortage of a specific component. These are the parts that are mass manufactured normally, but these were in short supply. So very quickly we can then redesign it to be 3D printed and we can start churning out parts the minute we have a CAD model.
And with regards to the colours, you've got a blue ring around the top there. You've actually 3D printed that as well, so you can separate all the parts differently into their different sections because they're all different, aren't they?
So these are basically flow devices that deliver oxygen to COVID patients.
Wow.
And each one of these has got a different flow rate. So although they look the same, the internal geometry is different.
And
the colour band just identifies for the medical staff, this is a flow rate, for this patient on this machine.
Okay, so the next part, again, this is exciting because this is where we're talking about creating a tool. And when we talk about injection molding, that's ultimately what you're doing. You're creating a tool and then injection molding. Whereas actually you're creating the tool and then pushing the material through your own tool.
Yeah, I mean, in some ways, the 3D printer is the tool.
Yes.
Yeah, in some instances. In other instances where we don't have a material that satisfies the customer, we can produce tooling. This is an example of indirect manufacture. So what we've actually printed here is an eggshell mold. And as you discovered earlier, this is a really brittle part.
It is.
By design. But basically, we inject a silicone or a rubber into the mold. Once that solidifies, we then just literally break this and crumble it into pieces. So it's designed to break.
Wow.
But the actual finished bit is the rubber part that we take out.
Look at this. You're creating a tool and to create the ultimate. I'm just fascinated by this. And material. So this is quite almost like an exotic material here, isn't there?
Yeah, you can see here, we sort of break down our materials into 4 or 5 categories. So we've got the prototype materials that you might use day to day, quick, dirty, developmental materials. We've got our sacrificial materials, and then we've got our exotic materials. And exotic materials, they tend to excel in one key characteristic.
Yes.
This particular material is designed to withstand incredibly high temperatures.
Wow.
So this will withstand 300 degrees Celsius.
Do you know what that's used for?
This is coming out of some sort of motor, so it's going to be whirling around. It's going to be generating a high temperature.
Heat, of course.
And we want to make sure that the part is not deforming or losing any integrity at those high temperatures.
See, that's the chemistry. That's the excitement about what this is all about. Is you're not just producing these machines, but you're producing solutions to people's problems. Now, I love this part here as well. It's kind of, I hate to say the word, but it's a little bit squidgy.
Yeah.
But I was surprised. I picked it up and I was like, wait there, but you're 3D printing this. How?
So this again is a big leap forward for us. You know, elastomeric or rubber-like parts are really difficult for 3D printing, and this is our next generation production elastomer. So this could be used for producing end-use bits, and it's what's called a Shore 65 rubber. So yeah, it will deform and come back to its shape nicely.
It's fascinating. And of course, there's some parts here. I know we've touched on some on the table, but this is quite large, right? Does that show the capability of the size of what you can produce in the machine?
It's probably about as big as we'd go with the Figure 4.
Yes.
You know, every printer's got its limitations and its strong points. There's a lot of advantages to Figure 4, but it's primarily for small and medium-sized parts. But we can go quite large, quite tall in the objects we produce.
And what's this used for?
I believe that's actually some sort of transmission arm. So it's a part that will ultimately be cast in metal, probably aluminium. But while we're going through the various design iterations and the development work, you know, we're 3D printing it off in plastic because it's quicker and cheaper, and we can check to make sure things are fitting together before we start casting real expensive parts.
It's amazing. Right, anything else you want to add? Because I love the fact that, you know, we talk about injection molding and we'll cover the batch production and everything a little bit later on, but, you know, you're making internals as well. That's something that only really new, you know, some of the latest technology, you know, we're learning about.
I suppose the benefit of additive is that, you know, we always say complexity is free. So if you've got a very complex geometry that's difficult to tool or injection mold or machine, you know, that's when 3D printing steps in. So most of what you will see here, you know, the parts aren't simple, they're complex, and that's when the advantages of 3D printing really kick in.
Comes in. Right, okay, we have had a question come in. Okay, so we'll ask another question we're going to move on and then we're going to ask some other questions. Sorry, we're running out of time. So, Paul, that pen is growing, so let's have a look.
Yeah, it certainly is. It certainly is, Lindsay. Now, just for people that have joined us as well, Steve, just tell them once again what people can get today for after watching this show.
Looking at investment of 3D printers, the old concept is the finished part itself. The finish and the ability to check that against the model that we've got. So we've got a variety of components to send out so they can test and destroy them, along with a brochure and a few other freebies that gives you the technical background on these two machines and the materials that can be printed throughout the two machines.
Okay, contact you at sales@engtechgroup.com.
That's correct, yep.
Yeah, and you can be the proud recipient of that. Somebody has commented in and actually said about, I should have used the word stationary, and I said that you didn't move.
Oh.
That would have been good, wouldn't it? How could I forget that one?
No, very good. Look, very good, Paul, yeah.
Okay, right, now, before we, part of this section is really to learn about some real-time applications. So the real-time applications that we want to hear that the Engineering Technology Group have been involved in that could maybe apply to people that are watching this, because that's really the key to this, Steve. Could you give us some examples?
Yeah, so we're, again, as a turnkey provider, we get wrapped up in all sorts of weird and wonderful projects. One that springs to mind was an automation project that we were involved in, where they were handling castings back and forth throughout the cell. What the customer was proposing to do was to machine a lot of small aluminium bases on their existing machines for these castings to sit in. We offered them a printer to be able to do this because the variation of components changed. So they're forever machining different forms of supports for them. By giving them the printer, it freed up their in-house machining to produce components, which they should be doing, while the printer overnight printed out the seats.
Now, we have had a question come in, which is quite pertinent to this situation, about someone looking to print jaws on a chuck for their Nakamura machine, as opposed to changing them. Is that something that you would recommend or could do, or they could save time as a result of?
Yeah, definitely. So obviously on the Nakamura, it's a production built environment machine. So again, as we keep alluding to, the spindle should always be turning. So for a customer to machine out the soft jaws, whether it be for the chucks or for the gripper arm, the machine isn't producing raw material, it's not producing components. So yeah, 100% the printer overnight can print a set of jaws for either chucks and can print jaws for the gripper arm itself.
Okay, now what about looking at another market for this? I mean, it's great to be able to add this into your capabilities to satisfy the needs of other machines that are being used for things at the moment. But prototyping is a big one as well, isn't it? Maybe if you were costing a job for somebody, you wanted to show them what you could make, you can do that quickly on these machines.
Yeah, so you don't need to go to the nth degree of buying in tooling to machine a particular part. Customers always want to see the end product. So with the printers, you print all the through ports, the vanes, all the complex needs, hollow parts, movable parts working together, as opposed to having to, again, using your machine, using your own spindles to produce these parts.
And I think that the big win as well is the fact that you've got a different capability. You know, you can go and win more work, new work, not just satisfy the needs of what you need internally, but you can begin a new production. You can become a bureau.
You can use it as your own bureau work.
Yeah.
We do exactly the same.
We've got another question coming here. We have an automated robot cell, and we're always making jaws for grippers, so that would tie in as well with
exactly
what we said before.
What we were saying, yeah. So
Yeah.
the grippers on the robot arms itself, again, if they're picking up a variety of different parts, then they're going to use different work holding.
Okay, and then we have another question. They're coming through thick and fast. Don't forget, you can ask Steve or Gareth and Lindsay on whatever channel you're watching this on, LinkedIn, YouTube or Facebook. Steve, we make our own product. We outsource our parts supplied in different materials to test. Could we do this ourselves?
Yes, so the idea of the printers is that you can change over materials, whether it be a hard material, brittle, rubber, the different materials that are printed react differently at different temperatures. So I know exactly where the customer's coming from. They can print their own parts internally rather than outsourcing that work for them to send the work back in for their own particular product. So they're creating their own R&D centre.
Just before we go back to Lindsay and Gareth and talk more about production on these machines, because this is a fascinating topic, Hi4, part of the group, you use this technology, don't you, in conjunction with making fixtures for industry?
Yes,
so you're a good example of.
Yeah, it's a busy unit over there. We use it in two forums. One, we have our own CMM inspection. So the guy in there uses it to create different platforms to be able to hold the part so he can inspect it. We also use it in terms of our bespoke fixturing. So if the customer, we have generally a model of it holding the component, but we always print out a 3D model of the fixture and present that with their component and show different pinch points, clamping points, through holes for hydraulics and so forth. So the customer gets a real feel of the finished product that we can load into their machine and visualise.
And as a result of Hi4 buying one, do they get an extra discount because they're part of the group?
No, we put the price up for them.
Price up here. Repair work as well, that's my final one. Possibility something breaks, something needs changing. You don't have to go and find that component, try and source it. You can just
print it yourself. Again, Rob Beckett in our spares department will be kicking us. But again, it's a perfect analogy of small parts that for consumables that are repeated. You can quite easily print them through the night or through the day. Yeah.
Good stuff. Okay, keep your comments and questions coming in. Now we've talked about development of parts, research in reverse engineering and all the rest of it. But what about production? Back over to you, Lindsay, who's with Gareth.
Thanks, gents. Right, okay, so back to yourself, Gareth. Production, batch work. Where does this sit with injection moulding machines? Is it a competitor? Does it work alongside them?
I suppose, the first thing I want to say, I suppose before we can really start talking about producing end-use bits, really the material is the starting point. So we can produce parts that rival the quality of injection molded. Only some of our materials really are what we class as production grade. Today we're using Pro Black 10, which was our first next generation production material. The key thing here is that this material is environmentally stable. So once we've printed the part, if we were to test the mechanical performance on day one, we're going to accept the same mechanical performance 1 year, 2 year, 3 years down the line.
Right.
So we're using our production grade material here today. And I wanted to give you a real example.
Yeah, like a case study.
Yeah, you know, we're printing the pens, which is great. It showcases the technology and the material. But I suppose I want to talk about the economics of, you know, when it's viable, when it's not. So this is an example. This is actually a temperature sensor from a water house pump in your car. You imagine the,
Right, yes.
the windscreen wash. Sarah touched on this. You know, we bring in the CAD model. The software basically is going to help us orientate and decide how we print that. And then we can stack for a batch production. So on the small machine, we're going to run quite short prints. Here we're building a stack or a nest of components. And this is actually 120 parts that we can make in 5 hours.
Wow.
So that's key.
That's right.
The other key thing, I suppose, about that is we want an efficient process. So here you can see this is how the parts will come off the machine. And all of the material is being used for parts. You've got tiny, tiny amount of material that's
Little
used
connectors.
for connectors and for support. But basically here is the 120 parts in 5 hours. We can't show you the full process today. You know, there's always a bit of work to do up to the end. But all of the work that's involved in printing, you know, you need to consider that if you're going to calculate how much these parts cost. So when we've printed the parts, you know, essentially there's going to be about 3 hours of bits and pieces going on afterwards, whether that's cleaning, drying, or curing. Most of this is passive, so this isn't involving intensive labor.
Yes.
You know, you set the machine running for
And
an
then
hour
it's left.
and you leave it.
Yes.
But ultimately, what we're getting out of this machine is 90 parts. You know, these ones are costing around 40 pence. These ones are costing around £2. Important. That might sound expensive, but we've bypassed the tool here.
That's what I was thinking.
Yeah.
It's like with injection molding, you've got to create that part, plan that part. And injection molding, a lot of those tools have quite a high or a steep cost to them.
Very steep
So-
cost, steep lead time. This is the cost of these parts, including everything. The cost of the printer, the cost of the materials, the cost of the person doing all of the post-processing. You know, at the end of it, a highly efficient process, we're using 7 kilos of material and 99% of that is in the finished part.
And those are the parts that you've shown us.
These are the parts that should
Yeah.
be coming off the machine any moment now.
Yeah.
So, yeah, you know, the task with this was to make 2,000 parts as quickly as possible.
Yes.
And with the Figure 4 engine, we can turn out about 2,000 in 4 days.
Wow.
So that is batch production on a 3D printer.
On a 3D printer,
Yeah.
because a lot of the time I think I don't know if you're like me, but I would think, okay, prototyping one-offs and everything, but you've kind of opened my eyes, and to actually have a case study to see how much it is, how much it costs, shall we say, per part is pretty incredible. I know we've had some questions coming through. Have you got anything else to add?
I suppose you did question earlier, you know, will we replace injection molding? My answer would be hopefully, in some instances. You know, what you've got here really is just a graph that shows you the value of injection molding. And this really comes when you've got very high volume. So if you're going to make millions of parts a year,
Then
you're still going to mold and tool it. However, if you're in the thousands of parts per year, or you're making components where the design is changing every few months,
yes.
then, you know, we can compete on lower volume and on high design iterations.
But I also think about internals. You can't do that on a lot of, you can to a degree, but this is just on another scale.
Yeah, there are geometries that you can sometimes only 3D print. You know, one important point to remember, if you are designing something to produce with a 3D printer, typically you can economize and optimize the design for it to be
Yes.
3D printed. And then you end up with geometries that by definition are very difficult to produce with other manufacturing tools.
It's so interesting. Literally, you've opened my eyes to this. We've got a question that's come through from Les Priest, actually. What material are the pens being printed in? If it's a plastic-based material, are you going to talk about metal-based materials?
So it's a plastic acrylic. All of the materials on this Figure 4 are acrylic-based,
Okay.
which might be a surprise because acrylic is fundamentally the same thing people paint their nails with.
Yes, of course, yeah.
All of these materials have come from an acrylic chemistry.
Yes.
So we then add various compounds to give us the different mechanical characteristics.
Yes.
This machine is for plastics only.
Right.
But, you know, the question of production and batches is something we address with our metal technology as well. Maybe we can do an event on that next time around.
So you actually can cover metals as well, but just not with Figure 4.
Not with Figure 4. We have 7 printer technologies.
Yeah.
2 of which are metal, 5 are plastic. So
Oh.
if you want to learn more about metal, you'll have to bring me back on another occasion.
There you go, Les. Great question, though. Thank you for writing that in. Right, we're going to head back over to Paul and Steve, and hopefully those pens are complete.
Yes, they are. Would you believe they are? In fact, both printers have finished printing, and Steve and myself are going to open the doors shortly. Steve, have to do this every time. Just reiterate what people can get today if they're watching.
Yeah, so we've got a package of printed parts off both printers to give you a look and feel of the quality of the print and the finish that you get, along with a technical brochure that takes you through the 2 machines themselves, the information on material that you can get provided with these 2 units.
Now, what we're going to do is let's open a door. Steve, I'm going to open mine and open yours. So taking a look at your parts there, well,
yeah.
mine are definitely bigger than yours, aren't they? Okay?
Yeah.
Look at that.
There's no ink in your pen.
So you can be the proud recipient of one of these pens, and I think this is a great opportunity today for people to learn about 3D printing technology and the fact that the Engineering Technology Group can support you on your journey on that. And just on that point, Steve, I wanted to ask you about your support and service on the 3D printing side. Very well known for being able to hold people's hands during their journey of buying the machines for cutting metals, but printing them, are you in the same position?
Yeah, so the nature of our service department is obviously built around the machine tools, and for 3D systems it's obviously a niche market. So we have our own dedicated engineers out in the field servicing the product, and we have our own in-house applications team prepping the machines like they have for us today.
Good stuff. Now we have got one more question before we go over to Lindsay and Gareth to close off the show. You could have your very own Madame Two Swords with one of these machines, Steve. And if you did, and you printed yourselves, which bit would you change?
My hair.
That's a bad answer. Thank you very much for watching myself and Steve here today. I'm going to go back over to Lindsay where she can have some more questions and wrap this live stream up. Thank you very much. Over to you, Lindsay.
Paul, you so made that question up, didn't you? They're having a little chuckle to themselves. Right, okay, we have had some questions coming in. I just want to ask you a question, sir. What is it that you normally come up against, Gareth, when you're talking about the Figure 4 technology and inquiries? What do you get asked a lot?
Well, you know, we make some pretty big statements about being production ready. So I suppose people are always wanting to know, are we really there yet? Do we have the material for them? In terms of industry and application, it can be absolutely anything, which is, I think, my favorite part of the job. But, you know, we are selling this machine to people that are just maybe in a design department and producing designs. But more and more now, we're moving and starting talking to production managers and, if you like, manufacturing engineers.
Yeah.
So bring us your geometry, bring us your problem.
Yeah.
And hopefully we can find a solution for you.
Honestly, you've opened my eyes. Now, we have had a question come in from Leith Howarth on LinkedIn. Thank you for watching, Leith. So would a separate CAM system be required for modelling?
So if you think about it, 3D Sprint, the software that Sarah showed you, is the CAM software for the 3D printer. We do need a 3D file, if you like, to put into that 3D Sprint. So you will need access to a CAD package or the design file fundamentally. But we can do a lot of the work, the CAM type work, if you will, within 3D Sprint.
There you go. And will you help everyone with the CAM work, so the training of it, to understand it all?
Not me, but thankfully ETG have much better qualified persons than me. You know, the hardware itself is really simple, so you can self-install the hardware. But as with any technology, if you want to get the best from it, I'm sure ETG will actually deliver some commissioning, some
training and everything.
Yeah, because we have to.
You need your handheld.
You do. You know, once you do the training, then you're a beginner.
Yeah.
So, you know, ETG is a solutions company, and before anybody's going to buy this technology, we'll have fixed their problem for them, and then we want to train them to deliver it.
Right, we've got another question. Thank you, everyone, for writing these in. Also, we're monitoring the questions, so if you're watching this post the live event, don't worry, still write that question in, because they'll automatically go through to ETG as well. So, right, what's the quality of part like compared to injection molding? Oh, okay, so really comparing the part, what's the
does it genuinely compete?
Yeah.
I mean, the answer, it does. You know, we're delivering a surface finish and an accuracy and an aesthetic appearance that, is pretty identical to what you would take out of an injection mold.
Yeah, another question. What production grade materials can you print?
So I think at the moment we have 3 or 4 production grade materials. We have an elastomeric rubber material. We have the rigid black, which is what we're printing on today.
Right.
We have the rigid white, which was launched yesterday.
Yes.
And I'm sure more will come. Typically, we release a few materials every year.
Yeah.
The rigid black and the rigid white are really good, I suppose, for biomedical, consumer goods, consumer electronics, those sorts of industries.
Wow, okay, yeah, and it's the chemistry. This is what excites me. It's this chemistry that you have behind it all. It's not just the machines, but it's what you're putting into them as
They
well.
don't let me know the chemistry. That's
No,
that's the
top
secret. That's the secret value of the question. Yeah.
Well, exactly. Another question. Please tell me the price of the Figure 4.
So I think the standalone starts at around 19,000 for the hardware. So around a 20,000 investment, you'll be up and running and printing your parts.
Yeah, okay. I believe there's no more questions at the moment, but if you have any questions, like I say, we're monitoring those. They'll automatically go through Gareth and the team here after the live event. So do send them in. So thank you for watching. Thank you to the Engineering Technology Group for hosting the event today. And thank you, Gareth, as well for answering all of the questions with the
Thank you. I'm stealing my 3-minute pen. Yeah, I don't have one.
That's it, a 3-minute pen. Alternatively, if you are interested in the technology, and you can contact ETG, but you can also head over to the website, which is www.engtechgroup.com for more information. From myself, from Gareth, from Steve and Paul, thanks for watching, and we'll see you very soon.